XTERN Bootcamp Week 3, Day 1. Can you believe it? It's already Week 3. This is almost over. You're almost rid of me. So let's talk about React Router. Who knows how to read? Who doesn't usually admit to knowing how to read? All right. Let's hear from old Sam.
A JavaScript package that allows our UI.
What's a JavaScript package?
Is a React router.
Oh, React Router. Okay.
A JavaScript package that allows our UI to stay in sync with our URL. It allows us to render specific components based on which routes match or don't match the current URL path.
Heck yeah, it does. What's a URL? What's a URL? I don't want to know what it stands for. What is it? What's an example? What's a URL? Google.com. There you go. Perfectly valid URL, right? It's the thing up in the location bar. It's a web address. Allows our UI to stay in sync with our URL. So that's what routing does in general. Anybody ever used Ruby on Rails or Django or some other web framework? Anybody ever used anything with routing in it before? All right, well, it's a common feature in web frameworks. This is not something that's unique to React Router. And I didn't point this out in the morning, but React Router is not actually an official part of React from Facebook or anything. It is a third-party library, but it is a very popular one. There are other routing libraries as well, but React Router is the most popular. It was written in part by the same person as Rebase, Tyler McGinnis, who also has a ton of tutorials. So when you visit a normal static website, if you say /index.html, it'll just pull that file off and give it back to you. If you go to /about.html, it'll look for an actual file in the file system called about.html and give it back to you. But with React, we're building single-page sites, meaning there's only ever one actual page, index.html. But we can click on things, the URL changes, and the UI changes too. But you're never technically leaving that page. So that's what the router gives us. It gives us a way to translate the URL into basically which components should be on the page at the time. So that's what we're going to learn how to do. To get started, you add React Router DOM to your project. You don't need to do that right this second. We'll do it when we actually start a project. But React Router DOM, as opposed to just React Router, because once again, we are using the DOM version of React. There's also React Native, but this is for the web-based version of React, so React Router DOM. Just add it to your project. And then what you do is where you would just render your app component in index.js, you instead wrap that with a component out of React Router. So it's what's called a higher order component, which just means a component that returns another component. So basically, you can pass components into other components, which then return components. So that router component doesn't actually do anything with the UI. All it does is take our component in as an input and then add some stuff to it and return it. So among other things, it passes in some new props. So whenever we're using React Router, we have some additional props available to our components that it puts there automatically. So then we need to define some dang routes. So there's a route component in React Router. You give it a path, which is just a URL pattern that it should match. And then you can tell it what component to render. Not so bad. Now, that first route would also match /widgets/42. That still matches /widgets. So if you only wanted it to match exactly that without anything else on the end, you would have to add the exact prop, like in the second example. So that second example would not match /stuff/42. It will only match /stuff. And also, instead of saying what component it should render, like in the first example with a component prop, you can also actually pass it a render function with some JSX in it. So you can pass them JSX. Why might you need to do that? In this case, H1 isn't really a component. It's just a JSX element. So you could do that if it were a really short one. Or if, for example, you needed to pass in some props. So that top one, we're not passing any props into widgets. But if widgets actually needed some props, we'd have to use JSX. So we could use a render function to do that. And those are the basics. Now you need to be able to link to those things once they're there. You can totally just change the URL, and you can use regular old links too. Totally works. But there are link and nav link components built into React Router that give you some advantages. They pass in some props to your components that you wouldn't get the other way necessarily. So the difference between link and nav link, what they actually put on the page are, in fact, href elements. But you don't use an href prop here, you use to. So link to and then the URL. The difference between link and navlink is that navlink puts an active class on the link if you're already on that page. So if you have a bunch of links that are persistent across the top of the page, if you're on the About page and there's still an About link there, you want to show it a little differently to indicate that that's where you are now. So the navlink component will do that by putting an active class name on there. It's still up to you to style it, but you don't have to go to the trouble of checking which page you're on and deciding whether that class should be there. It'll do it for you, since it's such a common thing to do. Params. So if we were, I don't know, making a blog, and we had /blog, that gets you a list of all your blog posts. /blog/42 gets you a specific blog post. So those are two different routes. They show different things. But you don't know 42. You don't know that it's going to be 42. It could be 35 or anything else. So you need a param in there. So you can write a route like the one up there at the top. Route path equals /about/:name. By sticking a colon in there, that makes it a param. It renders the component user about down there. And then I mentioned earlier that React Router will pass in some props. History, location, and match are the props that it passes in. And the one called match will have your params on it. So props.match.params.name will get you whatever was in that name param. So if you linked to About Bob, props.match.params.name would be Bob. We'll see examples of this. It's pretty easy. So that's the match prop. There's also location and there's history. History mimics an object that's built in to HTML5. So the browser always has this history object that keeps track of where you've been. It's how the back button works and stuff like that. So who knows how to read? All right, Amari.
History. History keeps track of all the users' navigation over time. It can be used to programmatically navigate without using links. There are many useful history methods. Push, go back, go forward, go, and block.
Yeah, and there's even more than that too. So to programmatically navigate, so suppose you're writing a Twitter client and you go to the compose page. So maybe it's /compose. You write a tweet, you send it. Now you don't then click on a link to go back to your timeline. It just takes you back to your timeline, right? So you need to actually change the URL without someone clicking on a link. So you need to programmatically change it automatically when something else happens. For that, we need the history object. And React Router gives us its own version of the history object. So we can do things like go back or go forward, or push would be to add a new URL at the end. So go to a new page. And then the back button will still work. It'll go to the previous URL. Even if it's all technically the same page, It will put a new entry in your browser's history, and the back button will work the way you expect it to. So that is React Router in a nutshell, and we're going to be using it today, and it'll be a blast. Who's used Fetch? Who knows what the Fetch API is on the web? Yeah, tell us about it. Okay, so you can use it to make HTTP requests to an API or something like that. You can do get, put, post, any of the HTTP methods. So you do it asynchronously. We'll see that word in a minute. So if you see that word up there and aren't sure what that word is, I just said it. And if you were listening, then you would be able to read it when you get to it. So I'll know if you were listening. So yes, JavaScript. Still trying to make fetch happen. History is the wrong heading for this page. That should say fetch. So tell us all about the Fetch API, Christine. That's right. So a way for us to asynchronously make what we're interested in, HTTP requests, and to handle the responses. So back in the dark ages, we could not make asynchronous requests. If you needed to make a call to an API or anything like that, that was a whole new page load. So that kind of stunk. And then for a long time, we could do it with XHR or AJAX, which was also kind of a pain in the neck, especially as different browsers implemented it differently. Fetch is fairly new and is a very nice, easy way to do this thing so that we can make calls to APIs and so on without having to refresh the entire darn page. So that sounds like something that would go nicely with React too. But this is just built into the browser. You don't have to have React or anything. Again, params is the wrong heading. So the API is pretty simple. Fetch, pass it a URL, and that makes the request. And that returns something called a promise. Who's used promises? The same person who's used fetch and you. Yeah. What's a promise?
Promise is like it returns that, and it has a function called then, in which you can assign callback functions.
That is all true. That is all true. So basically, for anything that works asynchronously, in other words, anything that runs in the background, if we just put another line of code underneath fetch, it's going to run immediately after we call fetch, but fetch is happening in the background. So if we want to do something with the results of that HTTP request, it's not going to be available by the time we do the line underneath. But since it returns a promise has a method on it called then, to which we can pass callback functions that will not execute until it finishes. So it'll do the fetch in the background, and only after it finishes will it call whatever callback we passed into then. So in this case, we do something with the response. We parse some JSON from it, and then we think it returns us some user data, so we just log that to check it out. Then we could also call catch. Anybody remember catch from earlier? We used it with try. So this is a bit of error handling. So if there's an error along the way, if any of these things fail, it'll call the callback that we pass into catch. So that's how we can deal with errors. So let's try it all in a project. Questions before we move on?